Welcome back. This is Microsoft Virtual Academy. We are here for the jump start for C#. This is Module 4. My name is Jerry Nixon. I'm here with Darren. Welcome back, Darren.
Glad to be here.
What will we be talking about now?
We have the incredibly illuminating title of Features of C# Part 3.
Great.
But the overview is we're going to be looking at code reflection and obtaining type information from that process, and also working with garbage collection, which sounds incredibly interesting.
This is all very disgusting. All right, so first is code reflection, which is very powerful. We already talked about types and its metadata. We'll be getting into that. Beautiful. All right, let's jump into it and go to town here.
So, what is reflection, Jerry?
Reflection is reflection is a great name, actually. Reflection really does mean to look back. And then so reflection allows me to look back at my code or back at an object and interrogate it for whatever it has defined in its metadata. So I can say, for example, I'm looking at an object. I would ask, what methods does it have? I can use reflection to literally answer that question, to reflect into an object and bring it back to me. Over answered?
No, that's perfectly fine. So you talk about metadata, and so we've mentioned before when we're talking about types and how a type stores that metadata. So reflection is that kind of window into that metadata and allows us to use it programmatically, as well as allowing the compiler to interact and understand what capabilities are on a type.
And I can find out all kinds of things from an object, including just its simple name, but also its family. So where it comes from, what it inherits, what namespace it's in, what assembly it's in. A lot of information.
Yeah. And so, why would that be useful?
Well, it's useful for a couple ways. Wow, my goodness, there's so many
exactly.
implications.
The mind boggles.
Oh, man. Well, for one, it could just be interesting, right? You receive an assembly from somebody else. It's poorly documented, and now you need to be able to understand it. You could use reflection for that.
Okay.
There are tools that already do that for you and bring it to you in a graphical way. But in a programmatic sense, it might be because you want to reach into an object, and you want to be able to get information that may or may not make sense. You give me a whole series of objects. I want to get the name, but first I'll check to make sure they even have a property of name, and I go through that because I don't have an interface to help me with that. So instead I can use reflection to verify a structure. That's one option.
Okay. So you might be interacting with something in a more dynamic way. You wouldn't choose to do this over and above the way that we've been interacting with them thus far by creating an instance of the type and interacting with them in a strongly typed way by invoking their methods.
And I think the reason is, and this is worth remembering, is reflection isn't free.
Yes.
It can be very costly to do reflection. That doesn't mean you shouldn't do it. It just means you should do it with care.
Yeah, so basically the compiler, when we're interacting with the objects in the more traditional sense, knows exactly where the method is and doesn't have to worry about going and finding it and so on, and produces very efficient and optimized code. Whereas if we're using reflection, we have to interrogate the metadata of a type and then interact with that in a different way.
Consider is that we showed earlier. If you were going to see if an object is a dog, in order to use reflection for that, you would have to check all of its properties are present, right type, whether or not they're available, its methods, and all this other business.
As you mentioned, we'd have to walk up that tree because we would need to find, okay, does this type inherit from another type other than object? Yes, okay, go and get that type. Is that on there? No, okay. Does this inherit? And so on and so forth. So we would have to walk the tree.
Reflection itself is expensive, but this constant iteration is expensive as well. That's the reason we have these other ways. However, reflection is great, and there are right times to use it.
Exactly. Some typical scenarios when you would use it are dynamic extensions of your application. If you want to load a module at runtime that may be dropped into a directory, you could dynamically load in that assembly, and then you could use reflection to go and find, okay, are there any implementations of a specific interface in this assembly, and so on. It's very, very powerful, but let's kind of get to the nuts and bolts.
Including if it has a constructor and all these other pieces so you can interact with it properly. That is an interesting dynamic way to do it. Speaking of dynamic, it might be, you could flag your code so you could inject things into it. And that flag is, you could reflect to find all the flags.
Okay, yeah. That's harking back to the attributes.
That's right.
Attributes, I guess you have.
That's right.
Okay.
Attributes.
Indeed.
Yes.
So how do we get this type data using reflection? I mean, there's actually two ways. We can do it at compile time, should we so wish. If, for example, we know that we're going to be interacting with a type of dog, we can use the keyword type of and mention the class that we wish to get the metadata for, and then we've got that type information available. You might argue, if we already have the dog type and we already know about it, why would we do it? It's a good question, well asked. The framework supports that anyway, should you need to. The other way we can do it is at runtime. We can...
one of the reasons you might is because of methods on the type that
Absolutely.
you might need to interact with it.
Exactly. Another way you can do it is at runtime, you can interrogate an existing instance of a type and call its getType method. So that is evaluated type. Runtime will return back an instance of type.
Both techniques return a type. One is on the definition itself, one is on an instance.
Yeah. So the type class represents the metadata that any type in the managed environment returns.
Makes sense to me.
Okay.
Makes sense to me. It is nice. I mean, if you're interacting with a list of something, you can interrogate what type it is and change your logic based on it. And it's also, you could use it for security as well, to make sure the types that people are passing you are not invalid, not from a type-safe sense, but from you shouldn't be using this type of user in this operation.
Yep. Okay. So typically, once you've got a type, if you actually want to start interacting with it at runtime, you want to call its methods and so on and so forth, you need to get a hold of an instance of that type. So there's a couple of different ways that you can actually do that. There's a nice utility class called activator that's in the system.reflection namespace that has a create instance method with a number of overloads of that method. The first one that was around since C# 1.0 just returns back a object which you would need to cast into the type that you're looking for. So this, on the right-hand side here, you see var new dog is equal to a dog instance. We're casting the result of the create instance method, and we're passing in the type of dog so that the create instance knows how to go and create an instance of this. That is basically calling a default constructor on dog to return back that instance.
Now, there is, of course, a way to call more than a default constructor if
Absolutely,
you want to.
and
of
we'll
course,
touch that
and we
later.
have generic dog, which is using a much nicer implementation, right?
Yes.
We're using generics, saying the type that will be returned. We don't have to do a bunch of casting. This is our way of communicating directly to it. Look how readable that is in the second line compared to the first.
I know there's been a couple of questions about, what is really the value of generics and so on. I hope this really gives you a good example because you know exactly what type the create instance is returning. And inside that create instance implementation, it's optimized to be able to deal with these types.
Yeah, that's right. It's very powerful. Now, being able to reflect and create an object just knowing its type, that's really neat. I mean, I can really start to use it without having to say equals new dog because I may not know new dog, right? We say dog, but it might be T.
Yep.
Yeah.
Absolutely. And so what we actually have here is showing how you can move through the constructors of a given type and actually bring those up. And actually I noticed a typo on this one, that shouldn't be null at the bottom there, that final parameter. That should actually be passing in an empty array of objects, which should be the parameters passed. So that's a mistake on here.
That's in case the constructor takes 2, 3, 4 different parameters, arguments, different things to come into it.
Exactly.
Oh my goodness. Then there I can put them in an array, pass them into it.
Exactly.
I can't do it explicitly because it doesn't know. You're invoking an unknown method, so it allows you to do that with an array.
Correct.
Yeah, that's nice. So probably that's handy. I've done that a dozen times in my career. What I've done hundreds of times is reflect into a property. That's
exactly. You've already been passed a constructed instance,
yeah.
And so then you want to interact with that. And so there's a number of nice utility functions that are exposed out that allow us to interact with those. What we're showing right now is a slide that shows how you could interact with properties.
Yeah, that's right. And so, first of all, you get the type. You just can't forget that step, right? You get the type, and the type itself will give you its property. And once you get the property from a type, it's not enough. You have to go back then to the instance if you want to get its value. So here we are, we have a horse, and it's an animal. Its name is Ed. And so first I get the type, and that's just animal. It's not the instance of what I have. I'm just pulling back animal again. And I can see there's a property called name. And of course, I can see that I've interacted with it already. And now that I have a reference to that property called property, it's not a reference to the instance of that property. So when I want to get its value, I have to pass in that reference of horse.
So basically, get property pulls in the metadata that defines a property at the class level, but now we need to turn around and say, and now we mean this property name.
That's right.
On an instance.
So when we see that line that says var property, the value of that is actually property info. It's just the metadata that's exposed for that property from its type. It has nothing to do with the property itself.
Interesting.
Yeah, it's really neat. It really is neat. And so anyway, that's a great way to get it. Of course, there's a corollary to set value as well, so you can interact with properties without having to know the type directly or whether or not it has a property. Of course, I can say if property is null, and then from there I can say if property is null, don't do it, right?
Yep.
So I can do a test as well, not interact with an object that may not have that property.
That's awesome. So how about methods? Can we do something similar with methods?
No, we can't.
Oh, that's a shame.
Yeah, let's go to the next slide.
Disappointing.
Yeah, of course you can, right? Reflection is how it all works under the scenes, and this is a namespace that exposes it to the developer so they can do it too. And so method, of course, is a natural one. It works, honestly, very similar to invoking a class and calling its constructor. And so just like before, we have our horse, and in this type, so we get the type, and method now is not the method. Just like before when it was only property info, now we have only method info, and it's all of the metadata exposed by the type about that property. It's specifically its signature, return types, whether or not it's public to be able to call in the first place. Just like before, where there's a method that allows us to call it. We're not getting the value of a method, we're invoking it. So you can say .invoke. Then we pass in the instance we want to invoke that on. In this case, horse. And so it runs it.
Great. So the demo project is 004, if you want to explore that.
I do indeed. Let me pull that up.
Here's one we prepared earlier.
Yeah, it's nice. All right, so here we are. Good. Dogs. All right. So this is very similar to the same process we were just demonstrating. So let me go down to the actual definition first, so we can see that we have a class. It's a dog with a property of number of legs, and so in its constructor we set the number of legs to 4. Right? So this is the default constructor. This is the one that's called automatically if you don't specify anything. And so by default it has 4. Or you can manually call a different constructor. This is an overload of its constructor to set whatever legs you want. Of course, you could set it in the property as well, but this is just to make the point. All right. So here we are. I'll go ahead and create dog. And what's interesting about it, I could use var like before. And var is a reminder. Var is just a shortcut, so I don't have to say this is a dog, right? But object is fun because I can bring it all the way down to the base of every type of class. So I can say object dog, and now dog really is a dog, but I set it as an object. It's nice, right? So now I can do anything to it. And I don't have to, though. I could do reflection against a strong type.
What methods are exposed on dog at that point.
So now dog dot. Nothing at all. These 4 methods that are in the ultimate base of object, and really nothing else. We know that dog has a number of legs, and so we can't get to it. If I were to switch this to dog, right, then it would be strongly typed to dog, and it would know I can interact with it like that. Or I could use var, and var will cast it back to
object.
An object. That's exactly right. That's because create instance doesn't know what it's returning. It just returns back an object. I need to cast it yet again. And so I could do that here as dog. And now because I've done that, of course the compiler is very smart and knows that var says, and var simply says, whatever's after the equals is what this is. There it is. All right, so now we've got dog dot number of legs is right there. Okay, so here we are. The first thing I want to do is find all of the properties inside dog. So the first thing I'll do is get its type. And I can say type of dog. Another thing I could say is dog.getType. The difference is whether or not you're interacting with the instance of the object or just the reference to its type. All right, so here we are. I have its type, and type has this property, get properties, returns an array of all of the properties. We only have 1 property, so it's going to be an array with a member of 1. And then I can get the property info. Remember, that's what we actually get from reflection. To get its property, and here I know that there's only 1, so I can go to its ordinal position. So many ways I could get it, right?
Exactly.
I don't have to say get properties. I could also say get property, and it just gets a single one, and I can specify its individual name of legs or whatever it is.
Yeah. So basically what we're showing here is just how rich the reflection API is. And, you know, some of the challenges sometimes when you're working with these very rich frameworks is there are so many different ways to solve a problem that often it's challenging to know exactly which path to take.
Yeah, that's right. Yeah, that's right. I would recommend our path.
But that's just us.
Yeah, no doubt. You know, I mean, this is where we're about now to we could get its value, but rather than get the value, so many other things you can do with it. It's checking it, and, you know, making sure it's there so you don't continue with an operation if something is missing. It's really nice. All right, so what are we looking at here?
That's just basically allowing us to iterate through. So instead of saying get property name, we could turn around and say we might be looking for a property that's deals with the specific type. So if we were, say, assigning a handler, and we had a property that said what the handler was, we could iterate through the properties and look what the value is, and then we don't even need to worry about, do we know the name of the property? Because in many of these cases, if we're reflecting over something, we probably don't know what the property names are ahead of time. Yeah, we're interacting with it.
This is cool because we're really introducing some interesting things here. So so we're looping through. Of course, we talked about for each in the last module. We're looping through all the properties, which are just property infos, not properties. And so we'll loop through each one, and then we do a quick interrogation. And it's interesting because property info will tell us the name, right? Because that doesn't have anything to do with the instance.
Yep.
And then we call equals. Isn't that an interesting method on a string? Of course, we know name is a string. Equals is it's fun. I mean, we're going to talk a little bit more about handling equality, but equals is looking for the value, not its actual.
Yes, because one of the key things when you're comparing reference types is it's checking to see, is the reference the same by default? And so if you mean something different, you have to be very explicit that you mean something different. And in the .NET framework, you have the ability to specify comparators and inject comparators into an equality statement. You can also turn around and say, okay, how should this comparison be done? So in here, for example, we've specified that the comparison should be invariant, i.e. not specific to a particular culture. You can specify to use the current culture. You can also specify things like don't look at case, don't worry about case.
That's exactly right. But that's important too, because often if you don't do that, you're going to have to call to lower, all these things you have to do, and you don't have to if you use everything properly.
Indeed.
This isn't even necessary. I mean, you could take it away and it'll default for you, but it gives you all this other power if you do include it. Yeah, no doubt about it. This is great, and so this is just, now I'm looking to see if number of legs is there, and if so, interact with it. Okay, and so here we are, setting.
So here's your setting value.
Excuse me.
Bless you.
Thank you. Yeah, so here I set the value. It's dog is the instance. Of course, remember right at the top, we created it with reflection just to be fancy. And so now we're setting dog to a value of 3. And there we are. That's tricky. And the third, and it's almost always null because it's a very special case when you want it, is whether or not there's any, what?
Index.
Yeah, and there rarely are. All right. So it depends on the type. It only depends on the type.
Yeah.
And then we write it out just so we can prove that we got it.
Here's so this poor dog only has 3 legs.
Yeah, it's that dog. That's Lassie with 1 S.
Oh.
Good. And now we start interrogating the type itself. So now we have our dog, and we want to get the constructor on the dog. This is because we're going to call it, and we need to understand it. Like, what do we need to pass to it?
And so basically what we're going through here is illustrating how we can iterate through and find different types of constructor. So the first one gets the constructor that takes no parameters. And if we look down here, we have that constructor. Then we have a second constructor that actually takes an integer value. And so this is how we pass in an array that contains the int type. And what getConstructor does here is looks for a constructor that matches that pattern.
Right. What we're not asking for is all the constructors you have. We're asking for a specific constructor, and to be specific, we say what the signature is.
Now you might say, okay, well, how can we always guarantee that we're only going to get back 1? Well, when we created the type, the compiler will have enforced the fact that we can only have 1 constructor for any given signature.
Goes back to method signatures. Signatures are unique.
Strong typing.
Right, so we know we won't kill that. All right, so here we are again. Now we're calling for, we're invoking the constructor, which will return a type.
Yep, and it's going to invoke the default constructor. So if we look at dog, we'll see the default definition of dog will set its number of legs equal to 4. So on that console write line, we'd have output 4.
It's sure better.
It certainly better had.
Yeah.
On the second one, we've actually got a very strange dog. It actually has 5 legs, and so we're invoking the constructor with 5, and that will be the output there.
In fact, let me run this, and let me step into it right here. I may not have set this. Let me go ahead and set it as the startup project, and we'll take a look. Okay, so we've already gotten it, and so if you look at the output here, we have 3, which is because it's reading from what we set, right? This is the line that reads the number of legs that we set because we are doing it through reflection. And then here comes the default constructor, and oops, F5 over here. And we create the first one, which the default constructor sets it automatically to 4. Then we use the custom constructor, which sets it to 5. Powerful.
Wonderful stuff.
Yeah, yeah. Interact with the methods, interact with properties, create the objects if we want to. A lot of power.
Now, we've really just touched the surface of what you can do with reflection in terms of interacting with assemblies, loading them in, moving through those assemblies, and so on. You also can interact with generics using reflection. And that starts to get to a little bit more complex syntax and so on. But if you find that you need to do that, there's a lot of good documentation on MSDN and elsewhere in terms of how to actually interact with those.
It's worth knowing you can. Sometimes that's the most important part, is just to know you can so you don't chase a rabbit.
To a certain extent, that's really what we're trying to achieve with this particular course, is really to open everybody's eyes to some of the richness around there, to give you those elements that you can focus on for passing the certification and so on. We're condensing those 5 days into 1 day, so necessarily we can't dwell on all of these subjects to the depth that perhaps they deserve.
Darren, do you remember a few modules ago we were talking about handling an event? And when you handle an event, it was like a string between that event and your listener and your handler. And so then there was this issue of you have this string, and then here we are in reflection, we're creating objects. Now there are a lot of consequences to memory. And we know, of course, that in a managed environment, that's handled with garbage collection. So let's transition over to garbage collection. Very fun to talk about garbage collection. It's not as gross as it sounds.
Indeed not, because you don't have to get your hands dirty on it.
Not at all. That's right. There's a garbage man.
Exactly, and that is the runtime for you.
Yes.
It's a garbage thing.
The runtime doesn't have a gender.
Indeed.
Yeah.
It is a thing. Let's call it a thing.
It's a garbage.
So what is garbage collection? Well, as Jerry just alluded to, it's the implementation of automatic memory management within the .NET framework and the CLR. And what it does for us is it worries about objects we're no longer using and cleans them up for us. The key thing to understand, though, is that it doesn't necessarily do it straight away. So, and there are many good reasons for that. One of them is performance, that it can be computationally expensive for the garbage collector to iterate through all its object store and to follow any reference chains to ensure that the object is no longer referenced. In order to do that in an efficient way, it breaks things up into a number of different generations. So those short-lived objects get reclaimed first. Those that have been around for a long time tend to be held onto for a little bit longer before they get disposed.
A garbage generation is complicated. Let me try with an analogy.
Go for it.
So imagine the Serengeti, right? We've got wildebeest running around. And it's the natural course of nature for families of wildebeest to run around the Serengeti. But we also have lions, and the lions are prowling around, looking for the baby wildebeest that strays away from its family, and it's out there by itself just causing trouble, and the lion eats the wildebeest. That's garbage. The lion is garbage collection.
I see.
Because what you have is you have your code, and everything's in the family. Everything's referenced. Everything is working the way it's supposed to. And every once in a while, you have these orphan events that go off by themselves, right? Or I'm sorry, orphan objects, right? They no longer have any reference. You're never going to use them again. They're off, and really all they're doing is taking up space and eating from the Serengeti when you don't need to.
So basically, it's harvesting the easy ones first before it starts looking at the harder targets.
That's the truth, actually. That is the way. I mean, there is a heuristic around garbage collection, and the lion really is the example of it's cleaning up all around, but it's leaving the herd, right? It's leaving your application so that everything is referenced and done properly, just moves on. But if you have to spend time now chasing out all of these things that you don't reference anymore so that you don't take up all the memory space with them, that's a mess for you. It's a pain. C++ developers do it today. .NET developers don't, because they have garbage collection that takes care of the whole thing.
So a good example of an easy victim for garbage collection would be a local variable that's defined within the scope of a method. When the method closes,
that's right.
There's your baby antelope.
It's over. Yeah. Now it's antelopes. Yeah. Exactly. Sounds delicious.
Indeed. Yum.
Now, it is important to say that for the sake of the computer that's running, garbage collection isn't free.
It's not
It's
free.
Doing work for you, and it is real work.
The lion gets tired when it runs.
It does indeed. Yes, sometimes those orphans are fast. Now we're eating puppies for breakfast.
We're stretching the
killing
analogy.
Orphans. Yeah. Right, okay.
Okay, let's move on.
It's terrible.
Okay. So, as you say, it's expensive. The system has an algorithm which determines when to run, and it normally does so when it detects pressure.
And it's not us that's doing it.
Exactly.
Right? Yeah, we don't influence it, but we can. No, we don't control it, but we do influence it.
But there are scenarios where we can.
Yeah.
And when we can turn around and say, I want garbage collection to run. And so if we look at this particular slide, you see on the right-hand side, we've got GC collect. GC represents the global garbage collector. We have wait for pending finalizers, which will come to what they are in a moment, and then collect again. When this is executing, everything stops. Your application waits until the collect completes, then waits for any pending finalizers. So these are processes that may be running on objects that are currently prepping for being collected, and then it collects again to clean up those ones that are just finished their finalizers. That's expensive, and you'll only want to do that in specific scenarios. Typically, when you detect that you have a situation where you have reserved a large amount of system resources and you wish to clear them up before you get out. So a particular scenario that makes sense is a Windows service. So those of you who may not be familiar with Windows services, they are pieces of code that you can register with the system that get run on a periodic basis. It may run once every 24 hours, once a week, or whatever. If you imagine one of these services that is responsible for, say, running through every file and working out whether it's open, it could, in theory, have a lot of resources. If, say, it's creating a list of all the file names, that takes up a lot of footprint in memory. Once it's finished with that list, it wants to get rid of it. It doesn't want to leave them sitting out there impacting other applications' performance. And so you could turn around and say, I want my Windows service to release all of those file names, all of the resources related to those, and to do it now. Then once I've finished this, I go to sleep for 24 hours before I run again. And so it's a very good way of being a nice citizen.
It's back to the analogy for a second. You know, you're about to create an orphan, and you know that it's an expensive, a hungry orphan, right? That goes out and is eating everything. You call in the lion.
Exactly.
Like, there it is. And so imagine a loop where I'm going through, and every iteration of that loop, I'm doing something very, very expensive, and at the end of it is something, I do release it, but I know that it's still referenced in memory, and here I go, that loop's going to start again. I could call GC collect and say, now it's time to clean house, and I'm going to have to do that in every loop, but I have to be careful all of a sudden. A loop that calls GC collect.
That's a bad thing.
Yeah.
But I think your intent is great. You know you've got resources that you want to let go of. How do you do it? If GC collect is bad, what's a better way to do it? And fortunately, it just so happens that we have a capability to do that. It's implementing an interface called iDisposable that effectively marks up an object as complying with what's called the dispose pattern that allows us to preemptively release resources prior to any garbage collection. And so that allows us to be a good citizen, give things back, and then let garbage collector do its own thing in its own time.
Yeah. So iDisposable, that's common. We see iDisposable all the time. I'll throw a caveat. iDisposable is not in Windows 8 app development, right? It's a different mindset. But in all of other development, we get to see iDisposable because of the way it communicates to garbage collectors. So it's an interface, which means I have to do it.
There's actually an interesting snippet around, you mentioned Windows App Store development. One of the things that has been done is the close statement has actually been coerced into a dispose to allow you to use using for closing, which is actually pretty interesting, and we'll get to that shortly.
Yeah.
So this is a definition. This particular slide shows disposable objects, and for sort of ease of reading, I've added in a definition of iDisposable, just so we can see that all it does is state that anything so marked has to have an implementation of the dispose method.
And that's it.
And that's it.
It doesn't say what it does in the dispose method. It doesn't say how big the object is, small, nothing else. And from that point forward, all we have is .dispose.
Yeah. And so we have a demo class here that implements iDisposable. You can see the syntax there. And it's got an implementation of dispose. And so if for example, we imagine that demo had a member variable of an array, and we instantiated the array with 10 million integers.
Yeah, so now it's getting full.
That space is reserved. That space is allocated to this demo object. In the dispose method, we could deallocate that by setting the array to 0. set it to null, get rid of it, release up all those memory. So that places that memory available for reuse again, even though the demo object itself hasn't been reclaimed yet by the garbage collector.
So this is our implementation of doing some mild garbage collection, almost.
I like to call it housekeeping.
Doing some housekeeping.
Exactly.
iDisposable is not appropriate for every class.
No, sometimes it doesn't make sense. If you're not actually hanging on to a significant amount of resources, then don't worry about it. If all your variables are in fact defined on a local scope, again, don't worry about it. If those things that you're exposing out should last the entire lifetime of that object, again, don't worry about it.
If your class represents a stream, if your class represents outside resource, something that's very expensive, even mildly expensive, now iDisposable works.
Exactly.
But if all you have is an animal class that has name and number of legs, iDisposable is not appropriate. You could do it still, but what are you going to do? Very little.
Yeah, you go through and set all your properties to null.
Yeah.
Not that useful.
There was a time in Visual Basic when that was a big deal.
Exactly. And that's, again, it's because you're generally interacting with external elements.
Yeah, that's right. Okay, so there's a simple disposal pattern. We know there's an advanced disposal pattern.
Yeah.
Now, give me the shorthand of that one.
Yes.
Okay. So we know there's an advanced, but we also have using.
Exactly. So the advanced version, just briefly, what this allows us to do is to deal with a couple of different scenarios where we're not only dealing with managed resources, i.e. those types that are defined within the managed runtime, but also with external resources such as COM and whatever. That this allows us to expressly go out and release those external types as part of our dispose cycle. We also introduce in here, if you look down the bottom, we have this little wiggly, then advanced demo. So that's the tilde symbol. That is what's called a finalizer. So that is the inverse of a constructor. And it allows us to perform operations at the end of the life cycle of a managed type. It's not very common that we actually need to do this. Typically, the only scenario in which you would do so is releasing resources. And this implements the advanced pattern. Now, what we have is, you can see we implement iDisposable. So we have a method that returns void, and it's called dispose. And inside that, we call another implementation of dispose with a true parameter, which maps to a disposing parameter. In here, if we're disposing, we can then release managed resources. So what you would have inside there is other managed types that implement the dispose pattern. And we would call dispose on those. So it would cascade dispose down what's called our object graph, our related objects. Outside of that, we would also then set to null any references to external, say, COM objects or whatever. So we release our reference on those as well. Once we do that, we're then remove the need to run the finalizer, which is going to call dispose. And so what we have then is, after the dispose method, we actually turn around and say GC, garbage collector, suppress the execution of finalize, suppress finalize, and we pass in this object instance which says don't run it. And effectively that stops us having to worry about the finalizer trying to rerun and redo dispose. If we haven't called dispose, when garbage collection actually runs, it will call our finalizer, advanced demo, which will then call dispose false. The interesting thing about this scenario is garbage collection will only run if we don't hold references out to other objects that are alive, so we don't need to dispose our managed resources in this scenario, hence we pass in false.
Yeah.
But we still let go of the managed objects. That's about as quick as I could go through that one.
It's tricky business.
It is.
It is. This is actually, if you are going to implement iDisposable, odds are this is
the way you're going to have to do it.
You're going to do it, yeah.
Yeah.
It's also a friendly way, so that you can call dispose without relying on garbage disposal to do it, or garbage collection to do it. All right. So let me show you a fun demo here.
Yep. Go for it.
So let's pretend I'm gonna read a file real quickly, and what's nice about it is when I read a file, it comes back as a stream, and we'll talk about streams.
So we want to see your desktop, yeah?
Yeah, let's do that. So let me set a fake path here, something like test.txt. This is how I would set up whatever the path is. Let's say it's a real file. This one isn't one. And I want to say, var file equals file.open, and then I'll pass in whatever its path is, and then a quick little note that I want to open it. Now, file, let me show you the type of file. File returns a stream. And so stream is actually it's a great example of something that is a resource that you want to release. And so now that I have it, this is actually locking the file.
Oh, that's painful.
Well, it's okay for me because I'm writing to it, but everybody else, you might want to use it.
No, so you don't like to share?
Yeah, I don't like to share.
Yeah, that's me.
So the reality is, while that's open, it's important that it be locked because I'm interacting with it and I can't have it be indeterminate, right? I have to know what's going on. And so it locks on purpose. That's a good word too.
That's like polymorphism.
Yeah, I know. It never stops, man.
Indeed.
All right, now, in to-do here, I have some sort of interaction with the file.
Okay.
And let's say I'm writing, reading, parsing, whatever it is I do to it, and then I'm done.
Okay.
And that's the end. And so I can't forget to release the stream, right? I can't forget to dispose of it.
I actually think you can forget.
Oh, yeah. Oh, yeah, you can. I shouldn't, I guess is what I meant to say. And so to do that, I'll say file.close.
Oh, what if you leave it open and try to open
well, let's say you do forget, which is what I really actually do a lot. If you do that, the file remains locked.
Okay.
And there are processes that will eventually unlock that, but there's a long period that suddenly this file is no longer accessible.
So if you try to open it again, you get an exception?
Yeah. So we're going to be doubling what we're going to do in a minute. But yeah, so if I were to run this again, access the exact same one into a different variable, like file2, that would fail because it's already locked and I can't access it the way I want to. However, if I call close, I could do it again here, and life would be happy. Because now it's unlocked because I've closed it. Now, because it is easy to forget, there is a nice keyword that we have. And that's the using keyword. It allows us to create a block. Of course, a block is just...
Hang on a second, though. Don't we have using at the top of the...
Yes, we do. Yes, kind of like type. So using at the top, just to be clear, which brings in namespaces so that we don't have to reference them completely, is really a different word altogether. And you can know the difference only because they're in different contexts. You certainly can't you can't do using namespace inside a method. You can inside a namespace, interestingly enough. But the using that I'm talking about is the one that defines the beginning and end of a block, and it looks like this.
Okay. So that's a key one. A lot of people get confused sometimes when they see that in here, and they think it's making some sort of reference out to something and can't quite work out what's going on.
No, you're right. Especially when you're just talking it, when you're just speaking it.
Exactly.
You know, you don't have the opportunity to see the context.
Yeah.
And so it's the same. Everything else is the same except for we're wrapping everything into using. And so if I were to I would take the same line that would reopen the file so I could read or manipulate it, and I would just jam it into the using description or the using definition, and then in its implementation, I could still have to do that would interact with file exactly like I had before. No change in the code. The one good thing you don't have to do is file.close, because as soon as it runs out of scope, which means it just exits that block, then it will automatically dispose of the object for you. It's very, very nice, especially with streams. It's not unheard of, but it's almost unheard of to see people interact with strings without using a using, partly because it ensures that it's always called correctly. So using calls
dispose?
Using will call dispose for you. Yes, that's exactly right.
So that's interesting, but you had file.close.
Oh boy, now here we go. Well, we'll talk about the difference between close and dispose in just a second. But before we do, I mean, so that we can make sure we cover it generally. It is almost uncommon. It is almost unheard of to see the interaction with a stream, not only because it makes sure that it's disposed of properly whenever it falls out of scope, but also because it allows you to visually see that you're using a type that it is a resource or does have a cost and does need to be disposed without you having to interrogate it to the next developer. I always think about that. You know, the next developer is going to have to figure this out. This is a good way to communicate to them, not only to be safe, but also what you're working with and why.
Yeah, it's very expressive.
It's very expressive. I will say there are times when you don't want to use using. There are times when you need to keep that resource open, and you need even from one method to a method, even when you're changing scope.
Exactly, and sometimes you can fall into a trap there if you just get into the habit of doing using and then you try and return these things.
Yeah.
You know, the framework is actually very clever around how it manages those things if you actually try and return a value from inside there. But bear in mind, you can get some gotchas there.
It does. So let's go back to dispose and close, what we were talking about. So if I dispose of an object, I really am destroying it, right? This is a trash can operation.
Exactly.
I dispose of it, I throw it away.
If an object is disposed, it is effectively unusable.
Right.
Even though you may still have an instance of it available.
By contrast, let's say a file, which is a good example. A file that I close, I'm not destroying anything.
One hopes not.
I am closing that lock. And I could, right after close, I could say open again. And that allows me to have kind of this toggle on and off depending on cases. And so one big difference between dispose and close, well, probably the big difference, is that dispose isn't reopened, right? It's communicating to the developer this is the end. A close communicates that there is an opposing open. And you can call that open again if you want to, right? But there is also another case, right? We could dispose, we could close, or we could stop. And stop is different. You don't see it quite as much. You made the point earlier that close is can also use a using, especially in Windows 8 development. But stop is different. How is stop different?
Well, stop again it's contextual, I think. You have close, which you tend to talk about things that you've opened. Stop tends to be associated with things that you start. So you might have a timer as an example. You start a timer and you stop a timer. You might restart that timer. So again, these are almost verb actions that you're placing against these methods or these objects to interact with them. One of the key things is, by convention, if you have something that you stop or you close and you're implementing a dispose, you want to ensure during that dispose implementation that you close or stop what you're calling. And so that's why what Jerry was doing before worked, in that he could dispose the interaction with the file stream, and the file stream went, oh, I'm being disposed, therefore it would make sense if I close any streams that I have open.
Right.
Which is pretty slick.
Yeah, and so if I dispose, it's destroyed. If I close, then I could reopen, and it maintains at least a pointer sort of reference to it. But if I stop, it maintains its state, so that I could start and it comes back to where it was actually stopped.
Exactly.
Yeah, it's really nice.
Sounds good.
Okay. A lot of things here in garbage collection and working with streams. There are a couple penalties to not handling things like this correctly. One of them, of course, we talked about locking the file. Another one is it sort of locks the memory. Sort of makes it so that we have what we would call a memory leak, and so we maintain all of these resources when we don't need to, and our application suddenly has a nice footprint, and it's getting bigger and it's getting bigger.
So you mentioned memory leaks, and we've just been talking about how great garbage collection is in the managed environment. You know, it manages all the memory for us.
Why doesn't it solve this problem?
Why?
Yeah.
You know, that seems crazy. And so there are a couple of little gotchas that you can fall into when you're building these things. What you have to understand is that garbage collection looks at an object and sees, is this object referred to by any other object? And if it is referred, then it will not collect it. And so there are ways that you can actually create relationships between objects whereby you've created that reference and you haven't explicitly released it, but then you've removed your ability to interact with that object, so you can't ever get back to it. And so it kind of sits there out there as it should be orphaned, but you're hanging on to a reference to it, and so it never gets garbage collected. And if you're doing that in an area of the application that gets called repeatedly, then you keep allocating memory without releasing it until you close down the application. That's really the definition of a memory leak.
Now let's go back to the event, because this is the one that I think really gets people as well. When I listen for an event, I am making a reference now to that object and the one that's raising the event. And so
it's actually strongly coupled rather than loosely coupled.
That's right. There is that string between them is tight, and it doesn't break. And even though it falls out of scope inside your application. You know, what might happen is I'm interacting with that dog that's going to bark, has spoken, is being listened to by a trainer, and that dog is now gone out of scope. I feel as if I've deallocated it. But the reality is, as long as there's a trainer listening, it's always there. And even though I can no longer interact with it, garbage collection will not collect it. And so if that dog happens to be an expensive resource taking up a lot of memory, and I create dogs over and over that we listen to, and I'm always having that event handler being listened to by a trainer, all those dogs really are still taking up all this memory in my app domains, but I am not able to collect it until I break that reference. But I'm not breaking the reference because all I am is trying to deallocate it from the dog's perspective. How do I break that string? That's the thing, and I think this happens a lot, even in Windows development and standard development, where I'm listening for, let's say, a window that's open in WinForms or WPF development to have some event that fires, and then they close that event, but then they may open up or close that window, and then they may open up another one, and I listen for that one, and they close it. And little do I know that all those windows are still there, even though I can't interact with them anymore.
That's crazy.
It's brutal. It's very dangerous because it turns out that's a bad case of memory leakage.
Yeah.
Yeah.
Okay, awesome. So that sounds scary. It sounds like you're alluding to a couple of coding practices that can be used to offset that. And so one of those is, typically if you're binding to events during a loading activity, you may want to release that subscription to the event during an unload activity.
Yeah. Earlier we were talking that you can handle an event with that plus equals.
Yep.
You can unhandle it then with the minus equals, and it removes that delegate from the delegate list of the event.
Awesome.
Yeah.
Sounds like a good practice. But it sounds like there's probably some other scenarios that we can do around those references. That maybe we've got something that is listening, but we really don't care to keep it around if it should be disposed of.
And back to this interesting analogy of a string it's a much thinner string, right? There still is this connection between these objects. We call these weak references. So we have a standard reference or a strong reference that really does keep the reference from being collected. But we can also establish a weak reference to another object, and then garbage collection will see that and say those don't matter, right? Only strong references matter.
So if there are only weak references on an object, the garbage collector will dispose of it.
That's exactly right.
That's perfect.
That's exactly right. So back to our wildebeest. If the wildebeest runs away, and the herd is watching it, that might be a strong reference. Everybody forgets it. That's the weak reference.
Okay.
Along comes the line.
So if I have a weak reference to something, I can just check its value to see if it's null. If it's null, then the reference has been deleted basically because the garbage has been collected.
No. Oh, because garbage has been collected.
Exactly.
Yes.
Yes.
Exactly right.
Well, I'm glad we agree.
Yes, now we're back on board.
No problem. But there may be a situation where we're doing an atomic operation where we've checked, do we have a value in this weak reference? Yes, we do. Okay, then I'm going to do this, this, and this on that object.
So I've implemented the pattern where it's a weak reference, but for this moment, make it a strong reference.
Yeah.
Yeah.
I mean, how do we stop it from being collected partway through?
Well, the quick way is to create another reference.
Okay, so we create a local variable that then points to the value of that weak reference.
Right.
Okay.
And then that reference is the one that keeps it alive. Yeah. So we haven't really changed the weak reference to be strong. We've added another reference that holds it alive and keeps garbage collection away.
Perfect.
Nice. Okay. All about it.
Absolutely.
Should we should take advantage of the time.
We should.
No doubt about it. All right, let's look back. All right, so we had a big topic at the beginning, talking about reflection, the ability to take advantage of the metadata that is exposed from types so that we can look into objects that are handed to us to understand what they're like, what properties they may have, the ability to set and be able to read those values. That's really nice, as well as execute methods or invoke methods, and to instantiate an object by only knowing its type and interrogating to see what the constructor is and whether or not it has a specific signature and obeying that signature. Very powerful.
Very powerful.
Reflection is there. I think we talked about that reflection is both powerful and dangerous, right? Because there is a cost to it, and there are many, many other pieces to the framework that allow you to do most of what you're wanting to do. But there are times when reflection is the right solution, the best solution, all the way around, and you just absorb that cost.
And often the only way.
Often it's the only way. That's right.
Awesome.
And then we talked about garbage collection, and this is really more about memory management in the way that the framework will look at what isn't referenced, what's been deallocated, and it will suck that right out of memory. And then the mistakes that we can make by accidentally keeping things in memory even though we want them to be out, by creating strong references to those and the option to create weak references so that those can be removed.
Perfect.
Yeah, it was a good session, I think.
It was a good session. Covered a lot of ground.
Okay. Now it's lunchtime. This is the end of Module 4. Now we're going to take a...
Starting at 1. We're starting at the top of the hour.
We are going to take a break until the top of the hour, so I will see you all in 50 minutes. Bon appetit.